Hello, this video will serve as an introduction for getting started using SuperD within Rhino. SuperD allows you to use control cages to create smooth curved surfaces from rigid control cage source structures. So in the very beginning, what we're going to want to do is have a mesh that we can use as our control cage source, and we're going to want to convert that into the editable SuperD type. I find the easiest place to start is in the Mesh Tools tab within Rhino, and then the box type on the left, or mesh box type more specifically. So I'm going to click that, and then I'm going to click 2 times to create a 3D mesh box type. The important thing to keep in mind here is that the mesh box has an X count, Y count, and Z count of 1 in the source properties, and that the type of your mesh can really be any closed mesh, though I find that meshes created out of quad surfaces that are low poly count usually work best. So once you have your source box ready to go and you verify that it's a closed mesh or a mesh type of any kind, you can select it and then click the SuperD logo to create a new SuperD object for that type. You'll find in this case now that you can move your source mesh out of the way or simply delete it to reveal the created SuperD object. Once you have this object, you can click it and verify that it's a SuperD mesh type, which has its own properties that can be accessed from the SuperD logo on the Properties panel on the right. However, it's more useful, I find, in the beginning to click the control points icon on the SuperD toolbar to reveal the control cage structure. This structure is essentially what you edit to actually make changes to the SuperD object. So you'll notice that every single control point will dictate the shape and overall appearance of your SuperD object. If you want to do some basic editing, there's a number of tools on the SuperD toolbar that will allow you to achieve this. I find one of the most useful ones is actually the Subdivide tool, more specifically Subdivide Preserving Quads, which will split your selection based off of the edges subtending from the control points that you've selected and propagate all split edges around the surface while preserving quads to keep your object shape nice and clean. I also find that it's useful to make sure that you have the gumball turned on so that any time that you select SuperD control points, you can perform simple transforms without having to learn some of the more intricacies of how Rhino works. Another advanced editing feature of SuperD within Rhino is the pull feature, which allows you to perform a simple extrusion on the control cage, which results in extrusions that the underlying SuperD surface will follow. I find that combining these two features, namely subdivide and pull, allow you to end up with some very interesting structures while you're modeling using SuperD. To aid in selecting control cage bands that subtend across the surface, use the select ring function, which will allow you to select an edge ring all around your control cage surface, which then can be used to perform interesting edits to your underlying surface. Every SuperD object has a set of properties which you can define, which will affect globally the entire surface. To access these, select your SuperD object and then select the SuperD logo on the Properties tab. These two settings are the model resolution, which is self-explanatory, which will define the surfacing resolution of the entire SuperD mesh. And the other one is the fullness factor, which will affect the overall shape of the SuperD surface. In addition to changing the global fullness factor, every SuperD control point has a weight value, which will affect how much the surface gravitates towards that control point. Shown here is an example of what happens when a weight is drastically increased for a given control point. When neighboring values are set for vertex weights, an average of the two closest vertex weights will be used to compute the final result. Any file format supported by Rhino can be used as an input format for a control cage for SuperD. Shown here is an example of a control cage being imported from an OBJ file and then repurposed as a control cage for SuperD. Any Super D object can be converted into a polysurface by using the Convert Super D to NURBS command. Once this command is completed, you will be able to select the result and join all of the surfaces together to create a watertight polysurface within Rhino.